Okay, now let's discuss the overview of my project. And this project follows the RAG pipeline. RAG is expanded as a retrieval augmented generation, and it follows firstly crawling and scrapping, then embeddings generation, then storing in the vector database, and also query and retrieval. Let's discuss what is meant by crawling and scraping. This system allows the crawls and scraps the website content. What is the data present in the website? That is going to be scrolls and scraps. And the embedded generation is nothing but the scrapped data is converted into vector embeddings using a pre-trained model called all mini ALM L6V2. I will say in few minutes what is mean by this trained model. And then afterwards the embeddings are stored in the FAISS, a vector database for fast similarity search. Then, when the system is going to accept a user query and it retrieves the most relevant documents in the display them. So now I am going to sell what is mean by this all mini LML6 V2 pre-trained model, and it is a lightweight and designed for fast processing while still maintaining strong performance on the various NLP tasks. It is widely used in scenarios like RAG pipelines, semantic search, and etc. etc. Let's discuss an example. When you give the input as a sentence into this pre-trained model, it transforms the text into the vector that represents the semantic meaning of the sentence. These embeddings can be compared for similarity, enabling effective retrieval of relevant documents or content based on a user query. At last, it is a small transformer model that is used for the fast processing and all those. Then let's dive into the project. And the steps for demonstration is step one. We need to execute this scrap and embed uh, file. This contains the URLs what I selected and all those. Here it is going to scrap the content from selected website, these websites, and generated vector embeddings using this sentence transformer library. And these are going to store in the index FAISS technology. Then step two, coming to this query retrieve.py. This file consists like when we enter a query, it is going to convert it into embeddings, and it is going to search from the similar embeddings, and it retrieves the five relevant doc. Now, this file is nothing but it is an optional step, but if required, I also executed this to generate the detailed responses using the large language model. Then I'm going to deal with the demonstrating the output. Just open the new terminal in the VS Code, then redirect into the project directory. Then the files are present in this task folder, cd space task2, then click enter. Now, firstly, I am going to execute this file that is known as Python space. When we run this file, it is going to scrap the data from these three websites which we are select. Secondly, I am going to execute this statement like Python space query to get the response from the user query. What we give retrieve that. So when we are going to execute this Python space query retrieve.py file, it is going to ask us enter a query. By the way, we need to enter the query. Wait a while. So the enter your query. So for example, let's enter what research opportunities are available at Stanford. Let's click enter. The system is, for example, if you are going to execute this generate response.py file also, it's going to give like Python space generate response.py. It is also going to ask a query. It is an optional. You need not run this, but possible you can also do it. Let's enter a query. What research opportunities are available? Yeah, then editing. So it gives a response, and that response is saved in query response log.json file here in this. So this is the project. At last, I would like to conclude that this project showcases the power of web scraping, embeddings generation, and vector search using modern tools like FAISA and sentence transformers. So thank you for watching my demonstration video. If you have any questions or suggestions, feel free to comment. Thank you.